exercise 1 star question number 8, numbers 10, number 6 rather. The resistance R ohms of some wire is directly proportional to its length in L, length in L millimeters. So let's first of all get that relationship on paper. The resistance is directly proportional to the length of the wire. And somebody says, let's have some details here. A piece of wire 600 millimeters, a piece of wire 600 millimeters, that is, talk about length 600, has a resistance of 2.1 ohms. Resistance 2.1 ohms. Find the resistance of a 1.5 meters length of the wire. First of all, ladies and gentlemen, we have to convert this one to an equation, and every time we would want to introduce a relationship, we have to introduce a constant of proportionality so that it can become an equation, and therefore R is equals to KL. And for us to get the value of K, we have to substitute these details in the equation formed. The resistance is 2.1 is equals to K, which is the constant of proportionality divided by 600. And remember, these are millimeters. So to get K, divide both sides by 600 by 600. And therefore, 2.1 divided by 600 is 0.0035, as you can see. Now, our K is 3.5 times 10 raised to the power minus 3. That means from this position, the decimal point has to go 3 steps to the left now that it is negative 3. So this is 0.0035. It was here. It has gone 1, 2, 3 steps. That is the value of K, 0.0035. Now, we need to answer the first question. The first question is, find the resistance of a 1.5 meter length of wire. Please note, and note carefully, that the length that is given here is 1.5 meters. What we had before was millimeters. 1.5 meters, we have to convert this one into millimeters. First of all, 1.5 meters, to make them centimeters, you multiply by 100, which is 150. And to make this 1 millimeters, you multiply by 10. Simply because we have 100 centimeters in 1 meter, and we have 10 millimeters in 1 centimeter. And eventually, we have 1,500 millimeters. Now, part A of the question. Find the resistance of a 1.5 meters length of the wire. The resistance is, as you can see, resistance, which is not known, is equals to 0.0035. According to this, R is equals to KL, and our L is now multiplied by 1500. And let us see what is this. Times 1500. And the resistance is 5.25. The resistance is 5.25 ohms. That is the resistance of a 1.5 meter long wire. Part B, find the formula find the formula connecting R and L. The formula is now very easy because we simply have R, which is a variable. It keeps changing. As long as L is changing, the resistance also keeps changing. What is not changing is the value of K, 0.0035, and L keep changing. And that is the formula connecting R and L. Remember, R is a variable, L is a variable. They both keep changing, but K, 0.0035, is the constant of proportionality. And as long as we have a wire, that K will not change in this particular question. Part C, Thomas needs to make a 7.7 ohms resistor. How many meters of wire does she need? The resistance here is given. The R is, the resistance here is given. It's 7.7. What we don't have is the length, but the relationship is already here, as you can see. So we are going to have 7.7 is equals to 0.0035 L. What do we do to make L the subject of the formula? We divide both sides by 0.0035, 0.0035. And finally, as you can see, L becomes, let's have 7.7 divided by 0.0035. And what is that? 2,200 millimeters. 2,200 millimeters. But the question is, how many meters? We have just understood that 1 meter is equivalent to 1,000 millimeters. So 2200 millimeters, you simply have to divide by 1,000, and then you get this one in meters, 2.2 meters. And that is the answer to that question. So in other words, we are saying that if you want a resistance of 7.7 ohms, then you have to have a wire of 2.2 meters long. Thank you. Subscribe and share widely.